Alright, what's up guys? It's Probability by Pitman, section 1.5, number 4. Alright, so I'll assume you already read the problem, so I'm not going to bother doing that. Alright, cool. So, first let's draw a tree diagram. So, we're given R0 given T0, so I guess let's start with the T's. And then we'll stem down to the R's. Cool. Okay, so, given the information we have now, we know that P of T1 is 0.5, and since we know that each segment of a tree diagram has to total 1, so we'll say that T0 has to be the complement of 0.5 so that they both add up to 1. So 1 minus 0.5 is 0.5, and voila, look at that, 0.5 plus 0.5, 1. So this segment of the tree adds up to 1, which makes sense. Alright, cool. So we're given that R0 given T0 is equal to 0.99. So using that same logic, we can figure out that R1 given T0 is equal to 0.01. So 1 minus 0.99, complement 0.01. And then we can do the same thing to the other side. P of R1 given T1 is equal to 0.98. So we know that the outcome space has to equal 1 for each segment of the tree diagram. So we'll do 1 minus 0.98, the complement. We'll get 0.02. Right, cool, simple enough. And I think with that information, we can start problem A. It's the probability of a transmission error given R1. So we're given R1. So for transmission error to happen given R1, that means T0, because if it's T1, then there's no transmission error. Cool. So you'll notice that P of T0 given R1 means we're going up the tree, since we're given R1, and then we're calculating the probability of T0. Since we're going the opposite direction, that means we have to use Bayes' rule. So as a reminder, this is Bayes' rule. Yeah, okay, there we are. And I'll rewrite our part A into Bayes' rule. Sorry, T0. Alright, cool, simple enough. So P of R1 given T0. So using what we have here, we know that P of R0 given T0 is 0.99. So then P of R1 given T0 is just the complement of that, 0.01 as we calculated earlier. So 0.01. Here I'll highlight that. Alright. So now we're dealing with P of T0, which is simply 0.5 as we figured out earlier. Alright. And then the probability of R1, which is just these two parts of the stem of the tree added together. So we're just adding up all realities where R1 occurs. So that would be 0.01 times 0.5 plus 0.98 times 0.5. And highlight. Okay, I like these colors. Okay, so if we just simplify that down, that's just 0.005 over 0.005 plus 49. Yeah, and then that's our answer. You can simplify further if you wish. Alright, so that was part A. Now let's do part B. The overall probability of a transmission error. I think, okay, so the overall probability of a transmission error means that both R1 given t0 and and r0 given t1. Okay, so that just means we have to add up these two realities. So I'll just use my trusty highlighter. So that just means we want this and this. So that just should be and that there should be our answer. Alright, sorry, I just realized I did a slight algebra error after checking my answer. This should rather be a 0.01, or sorry, this one should be a 0.01, and this one stays as 0.005. So then we end up with 0.015. Yeah, this later came in handy to double check my answer. But I don't remember if I actually explained it. So basically, we're taking the chance that R1 failed given T0 times probably. So T0 and R1 and T1 and R0, and then adding those probabilities up. So those are the two situations where transmission failures can happen, and we're adding up those two probabilities. Alright, cool. Alright, for part C, it's literally the exact same thing, except you switch these values. So 0.8 and then 0.2. Or sorry, no, 0.8 and then 0.2, and you just do the exact same thing. So I'm not going to do that since it'd be pretty repetitive. But yeah, I hope that helped, and sorry for that slight mishap where I had to check my answer.